In section 4.4, we're going to study contingency tables and the associations that they can reveal between two qualitative variables. Now, this is an odd little section, and where it fits in the course pack kind of varies from semester to semester as we try to figure out a good place for it to go. It's in chapter 4 in the textbook, and that's because it's dealing with two variables simultaneously. If you remember chapter 4, the rest of it's all bivariate data, two variables. So you'd have scatter diagrams and you'd have linear regression, but that's because 4.1, 4.2, and 4.3 are all about two quantitative variables. But this section's weird because it's actually about two qualitative variables. So if you look at this example down here, for example, we have ethnicity, that's a qualitative thing. That's the row variable. And the type of course over here is the column variable. But the type of course is a word, American history, world history, right? So that's qualitative stuff. So it doesn't really fit very well in chapter 4. A better fit for it is chapter 5, because we deal with tables like this when we're dealing with probabilities. As a matter of fact, you've already seen tables like this earlier in chapter 5 if you're watching this between, say, section 5 or after section 5.3. All right, so we've already seen this before from earlier in chapter 5. This contingency table, or this is called a contingency table, also known as a two-way table, but it has two directions. It has the columns and it has the rows, and they work across each other. And that leads us to our variables. We have the column variables, which are the type of history course. That would be our column variable. And then we have ethnicity, which is our rows. So ethnicity for this particular example is the row, and the column is the type of history course. Now, every single box in here is called a cell. So for example, the African American World History cell is this 40 right here. So they want to know how many African Americans were taking European history. So I'd want to look at the African American row, I want to look at the European history column, and where those two intersect is this 20 right here. So let me underline that. And I'm going to highlight it just for us to be able to see it more easily. So there you go. So now that we know what these tables look like, and we've already seen these from earlier, let's scroll down here and let's look at the marginal distribution. Now, a marginal distribution means that you're going to be writing in the margins of the table. In other words, you're writing on the outside of the table. So that's what these total column and total row is for. Those are the margins of that table. So for this one, I want to find the marginal frequency. Now, frequency means I'm just going to add up. So I'm going to total. So for example, this would be 100 plus 40 plus 60, which would be equal to 60. There we go, which is equal to 200. So that total is 200. Now, I'm not going to show the work for all of them. I'm just showing it that one so we can see it. But essentially, you're adding up the frequencies and writing it in the margins. That's why it's called the marginal frequency. Get it? So then I would continue to do that for every one of these. So this is 160, this one's 140, and this is 100. I'm just adding those up in my head, but I'm pretty sure I'm right. Okay, so now that I have those, what about the column totals? So I would add these up. This is 300, this is 160, this is 140. And the grand total, when it's all said and done, these three column numbers and these four row numbers should add up to the same number if you did it correctly, which it makes 600, right, in the bottom corner. All right, so I made a marginal frequency distribution, right? A whole number of frequencies, I just add them up. Add up the rows, add up the columns, simple as that. Now I'm going to do the same thing, but with a marginal relative frequency. So I'm still writing in the margins, but I want to find how frequent each column and row was in relation to the group. So for example, this one right here at the top, this would be, well, there were 200 here, but it was 600 total, right? So this would be 200 divided by 600, which would be 0.3 repeating, like that. Okay, what about the next one? Well, the next row added up to 160, so that'd be 160 divided by the grand total of 600, which is 0.26 repeating. The 6 is repeating, by the way. And again, I'm just using a calculator to come up with those numbers. So then this one would be, this is the Asian American row. The Asian American row made 140. So this would be 140 divided by 600, which is 0.23 repeating. And last but not least is the Hispanic row right here, and that was 100. So that'd be 100 divided by 600. I'm not quite done yet. I found my row relative frequencies, right? So the Caucasian row, the African American row, and so on. But now I have to do the same thing for my columns. So I have to find each of those columns' relative frequencies. So if you look at the first column, it's the easiest. There's 300 in that first column, but I'm going to divide it by the grand total of 600, and that would give me 0.5. Then I'm going to do that again for the next column, which was 160. So 160 divided by 600 is 0.26 repeating. And then the next column is 140. So that'd be 140. And if you do this correctly, these three fractions should make 600 over 600, which is 1. And the same thing with these four fractions down here. They should all add up to 1. You should have all 600 people accounted for, but no more than 600 because there are only 600 people total in the group. All right, now how many people were taking taking American history altogether? So American history, let's look. How many is a frequency question as opposed to what percent? If they ask what percent, which would be like letter E, that's a relative frequency question. So relative frequencies is more percents, percent/decimal, whereas frequency is more how many, in case you're interested. So that's the difference between a frequency and a relative frequency. So frequency asks how many, and then relative frequency, these two words, would mean more percent. There we go. Okay, so down here when they say how many, that's frequency. So we're talking about the top table. So I'm going to go back up here and say American history, American history. There were 300 here in American history. So that means that our answer is 300. And just to help out things, I highlighted in yellow the how many part to let you know it's frequency. And I changed the color here. I called those red for relative frequency. That way when we get to those questions, it'll make it a little bit easier. All right, letter D. How many Hispanics were in the sample altogether? Well, if I go back up, how many is the top table? Hispanics is right here. So I want to know how many are in that row right there. So that would be 100. So that means that my answer is going to be 100. Now, for letter E, it asks what percent? Well, percent is going to be a percentage question, so that's a relative frequency question. So what percent of students were in world history? That's this number right here, the 160 divided by 600. So that leads us to 26.6% roughly. Oh, sorry, 26.7% if we round appropriately, because it'll be 666 forever. Or if you like, you could put 6 with a little bar over it. That would be fine. Now, what is the probability? Okay, again, that is a relative frequency question. Percent, probability, those are all relative frequencies. So what is the probability of randomly selecting a Caucasian student? That would be up here. The Caucasian students are right up here. And so the probability is 33.3 repeating percent, or 0.33. Technically, I've rounded a little bit there to do 33.3 rather than 33.3 repeating, but the point still comes across. All right, now we studied the basic parts of a contingency table with all its definitions, a frequency distribution, a marginal frequency distribution, and a marginal relative frequency distribution of that contingency table.